by the end of grade 3.
So I don't know, like they were doing it, but I don't actually think that a lot of them actually, I think they're just like, hey, 10 equals 1.
Yeah.
Like I don't think they really.
They don't have that sense of it.
Connection.
So they've had the experience of counting to 10 and knowing that somehow now I can have this thing that he's saying is equal to 10, but really they still believe he says it equals 10. They don't believe it equals 10.
Yeah.
Right? But I mean, it's not going to hurt them, but they know that that experience of counting to 10, that like the more opportunities we can have in early elementary, primary 1, 2, to count and build sets and separate them in different ways and see how they go together, and oh, I had 10, but now I have 3 red and 7 yellow, or oh, I have 4 red and 6 yellow. All of that stuff is going to help them later on. And so in our current curriculum in grade 3, we introduce decimal tenths and we do a lot of work with fractions. And what we're finding is that kids really aren't getting decimals and fractions because we're probably starting too soon, and we're probably not letting them develop their number sense solid enough before we start building on, okay, let's talk about fractions, okay, let's talk about decimals, right? So
they're doing less than and greater than with the fractions now in grade 3, right?
they just compare them by looking at them, yeah.
But not the less than and greater than?
I can't remember if we introduced the less than, greater than symbol. I think we might, but it's really as a way of recording what you've observed and not necessarily doing it symbolically.
Putting 1/8 as the bigger fraction all the time, then they don't have the concept of
right.
what 1/8
yeah,
is.
they do not. Right. Yeah.
Kind of like the cart before the horse, because they need to know.
Yeah, no, it's all about modeling fractions. The only time kids should be recording something symbolically like that is I've built 2 fractions, I've built a half, I've built a quarter, and I know 1/2 is more than 1/4. So then I would write that to show what I've seen, but I would never be asked to do this without the model, ever. Okay? Not until like middle school. Okay, maybe grade 5, which I consider middle school. Okay? So we want them to have lots of different opportunities to build an awareness of what fractions are. It's really important that they get kind of the whole notion that there are all these different models. And sometimes what happens, remember the other day when we read the article is 1 a prime number, and they talked about multiplication. If you only think of multiplication as repeated addition, it's sooner or later going to break down. Well, if you only think of fractions as part of an area, sooner or later it breaks down for you. It makes proportional reasoning really hard. It makes ratios really hard, right? So you need to have these different models because they, in different contexts, different models are going to be more appropriate, right? There are sometimes when a linear model is the most appropriate. There are sometimes when an area model is the most appropriate, and there are times when a set model is the most appropriate. Okay, so then I asked you to do some modeling, but I think we will. So I asked you to model some of the fractions like 1/4, but I think you probably got that okay, did you? So let's skip down to the comparing. Oh no, let's skip down to this one. You don't have that one? Oh, it doesn't look like that. It's called converting mixed and improper fractions, and it looks like a chart where you have 3 mixed fractions and 3 improper fractions. And you have to make one the other. It would be page 2 of 6. So you had to take 8/3, which is an improper fraction. Why is that called an improper fraction? Yes, Becky. Because the numerator is more than the denominator. When I have more stuff on top and pieces on bottom, It's improper. So improper. What does that mean, 8/3?
Means it takes 3 to make a whole. You have 8 pieces.
Okay, it takes 3 to make a whole, and I have 8 of those.
So you have 2 whole.
So if yellow is 1, hexagon is 1, what color would those pieces be? The blue piece, right? Oops. Oh, that's red. There we go. So we have 8 of these pieces. And what do we do to make that a mixed fraction?
Make all the holes in holes.
See how many holes you can make. Okay. Made 1. How many pieces do I need to make 1 whole? 3. So every time I can cluster 3 pieces together, I can make a whole, can't I? So I can make 2 wholes plus how much more? Plus 2 left over. So I have 2 and 2/3. Okay? So we want kids to think about what fractions mean in order to be able to do this. We do not want to write on the board, take the top number, divide by the bottom number, subtract what's left over, and then put that over the number, and then there.
Yeah, but we all.
I don't even know if what I said is right, because that didn't make any sense to me at all. Right?
I heard it the same way before.
So we have a lot of people, I actually, I'm not going to lie to you, I went into a grade 5 class one day where a teacher had asked me to come in and help him work with the students with this very concept. And he had written on the board, you know, an example, divide the top number by the bottom number, figure out what it is, subtract, what's the remainder, put that over the number, so this is your whole number. And they were like, yep.
I always did, like, if it was 8/3, I always said to myself, how many times does 3 go into 8?
Mm-hmm.
And then how many is left over?
Mm-hmm. Yeah.
I was always taught like so it would be
I don't know if I was taught that.
times multiplied by 2 and then plus the denominator.
Yeah, but that's going the other way. Yeah. And did you know why that was? Just because the teacher said, right?
That's
Yeah.
what we were doing. That's what we were doing in the after school program yesterday. And like I had to sit there for 5 minutes and think about how I was going to explain it and not explain it that way.
Really?
And now I teach them like just to multiply the denominator by the whole number and then add the numerator.
Mm-hmm.
And then I can sit there and try to figure out how to explain it.
So did you take out some fraction blocks?
Yeah, I did. And then I started talking about how many pieces it took to make a whole, and then how many pieces they had if they had like 2 whole, and
Yeah.
then how many pieces they had left over. And that's how I did it. And then I converted to it in drawing.
Right. So if I have 9 of the 1/2 pieces, how many holes can I make? Right? You will never need to teach a rule because kids will just figure it out, and they will eventually figure out that rule, like how many sets of 2 are in 9. I know every set of 2 makes a whole. So yes, I am dividing, but I'm not dividing because someone told me to divide.
No.
I'm dividing because I know for every 2 pieces I can make a whole. And I have 9 of them, right? The numerator always tells me how many I have of them, and the denominator tells me what size they are. It's the denomination of the fraction, right? So when I see a 2 on the bottom, it means I need 2 to make the whole. Yeah, Meg?
I'm just wondering, for proper and improper fractions, could improper fractions be bigger? Is that a ridiculous question?
Well, they're bigger than 1.
Okay.
Most of the fractions that we first learn And this is another misconception that a lot of kids get, that fractions are smaller than 1, right? Because normally we think of it as a piece of the whole. But fractions can be bigger than 1, and improper and mixed fractions are both bigger than 1. So what we do for mixed fractions is we figure out how many wholes we have, plus whatever proper fraction is left over. For an improper fraction, we just talk about how many pieces of that fractional piece we have.
So if you had like a list of fractions and you were trying to order greatest,
Mhm.
like is one of the questions
Yeah.
on here, and you had proper and improper, like
Your proper fractions are always going to be less than your improper fractions, because
that's what I would do.
your proper fractions are always less than 1, and your improper fractions are always greater than 1. Yep. Okay, so that's an important thing when we're talking about improper fractions. We want kids to have a sense of this is more than a whole. Because for some kids that's another thing, like we set these kind of false ceilings for them, right? So we have to be really careful that right now when we're learning improper fraction or proper fractions, we're just dealing with things that are part of a whole, but we could have things that come together to make more than one whole. Yep.
When it comes to like testing kids on their knowledge of this, I guess, for an actual the written test portion of it, would you allow students to use any manipulatives?
Yeah.
During it?
Absolutely. Anything you use in the learning, you should use in the assessment. In fact, when I taught grade 8, which is the big year for fractions, when I do my fractions unit test, they had to draw models, they had to explain models, and I sat up at the front of the room where they had to come up and model 2 questions for me. So they actually had a manipulative observation type of assessment. I had a TA in my room on that day so she could keep an eye on them while I was sitting up at the front with someone doing some fraction stuff. But it is important that they be able to model, and it's important that they be able to model in a few different ways.
I just, because with my grade 5s, I saw like, I never taught it while I was watching it. You always let them use it, but when the test came, they weren't allowed and like they bombed.
Yeah. Yeah, I would never do that. I would give them the models at their table. Some kids hopefully have had enough experience that they've internalized them so they can quickly sketch them, but they might just need to touch it, and then like sometimes you just need to look at the pink one and go, oh yeah, and then draw it in, right? Like you don't necessarily need to build the whole thing, but the visual there helps you to remember what you built before. But not only would I give them models, I'd also test them on their ability to do modeling, right? So, and that's important. It's the same for anything. Like when we're doing base 10, you know, if they don't have base 10 blocks at their tables, they, you know, you're setting them up for failure. So if I have 9 halves, how many wholes can I make? 4. Why? So every whole, let's relanguage this, Laura, okay? Instead of saying 4 times 2 is 8. Oh, 8 halves equals 4 wholes. So, okay, good. So every whole needs 2 halves. And I have 4 sets of 2 halves there, so I can make 4 wholes. And then I have 1 lonely little half left over. So I have 4 and a half. If I have 13 sixths, how many sixths do I need to make 1 whole? 6 of them. Yeah, it's kind of almost like a trick question, right? You think that it's crazy? So I need 6 of them. How many times can I take out 6 of them and make a whole? Twice, right? Because I have really 6 over 6 plus another 6 over 6 plus 1 more 6 over 6, right? Or 1 more over 6. Yeah. And so I have 2 and 1 sixth. Good. So it's really important that we not give kids rules, but we let them reason this out. And the reasoning comes from understanding what a fraction means. If they understand what a fraction means, they'll never have to worry about the rule because they'll just know it. right? They'll tell you, like, really all you have to do is divide 9 by 2, and that's 4. And so you know you've used 8 of them to bake your holes, and you've got 1 left over.